Alright guys, let's talk about linear relationship representations. Linear relationship representations. And I know we've done one similar to this before. This one's just a little bit different. Tammy signs up for a membership to rent video games. The company charges $5 per month. Remember, per, that's your sign that you're multiplying. And $2 per video. Okay. The question says the amount of money Kathy spends a month depends on the, because we're talking about for 1 month, the per month doesn't really matter because we know that's going to be 1. So we're going to focus on the per video, okay, which also means multiply. So the amount of money that Tammy spends a month depends on the amount of video games she rents, right? So the equation, we would say y, which is the amount of games that she's going, or the amount of money she's going to spend, would be equal to the $2 per video game plus the $5 monthly fee. So this is how much she's going to spend each month. Can be used to represent the situation where x represents the number of games rented, and y represents the amount spent, or the total cost, each month. Okay? Just a quick review, when we have something added or subtracted from our coefficient and our variable, that means it is not proportional, but it is linear. All right? Remember, the y equals kx represented our proportional relationship. This is now y equals mx plus b, which is our linear relationship. Okay, so when we go to graph this, in our table, remember we've done this before. This is our input, this is our output, and our process is that 2x plus 5. Okay, 2x plus 5. So I'm going to bring that down and say 2x plus 5. These are my x values, right? 2x plus 5. It doesn't change. It's 2x plus 5 all the way down. Okay, so 2 times 0 is 0, plus 5 is 5. If she doesn't rent any movies, she's still paying the $5 a month for the membership. If she rents one movie, that's $2 plus $5 for the membership is $7. We've got 4 plus 5 is 9. 6 plus 5 is 11, and 8 plus 5 is 13. Okay? If we look at the relationship that we have here, if we look at that constant rate of change relationship that we have, from 5 to 7 is plus 2, 7 to 9 is plus 2, 9 to 11 is plus 2, and 11 to 13 is plus 2. And then on the other side we have plus 1, plus 1, plus 1, and plus 1. So that slope is 2 over 1. Remember, it's always y over x, output over input, 2 over 1, which is 2. Okay? So when we go to graph this, we always do which variable first. It should be the x variable first, right? So my x is, if we look up here, number of games rented, and according to our top part, we said that the y was the total cost per month. Okay, so even if you forget that x goes first and y goes second, number of games rented is on the bottom. So when my number of games rented was 0, which, let's go ahead and put our points on here, and we're going to skip 1 in between just because we have enough space. So skip 1, this would be 1, 2, 3, 4, 5. Same thing on the other side, 1, 2, 3, 4, 5, 6. Okay? All right, so probably shouldn't have skipped any over here. Let's go back and fix that. Just because our numbers go up all the way to 13, so we're going to fix that. Hopefully you're using a pencil. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. There we go. All right, so even if you forget that X goes first and then Y, number of games rented, we have 0, 1, 2, 3, and 4. Total cost per month, we have 5, 7, 9, and 13. So 0 games rented is still $5. So that's your first point. 1 game rented is still $7. So that is your second point. Be sure to skip one in between. 2 games rented is $9. 3 games rented was $11. And 4 games rented was $13. Remember to use your straight edge like we've talked about. And draw your line. And the more movies she rents, the more money she's going to spend, correct? All right. Now let's check that slope that we did earlier, that 2 over 1. If I said I'm going up 1, 2, and over 1, is that accurate? It is. Even though we're going up 2 boxes and over 2 boxes, the over 2 is really over 1 numerically, right? Up 2 units over 1 unit, up 2 units over 1 unit, up 2 units over 1 unit. So we've made our stair steps there. Okay, and we're climbing up the stairs. It's a positive slope. Okay, let's look at this side. Same title on this side, linear relationship representations. Okay, so it tells us that slope is the change in the y values over the change in the x values, using the table to compare the 3 different sets of value. We would say rise over run. It's going to give us 2 over 1. We also could go from the 5 to the 9, which that rise over run, let's just say we're going to say 9 minus 5 gives me 4. This was, let's just say this was the 7 minus 5 and the 1 minus 0. And I'm getting those points here. 7 minus 5, 1 minus 0 gave us 2 over 1. Now we're going to skip this one and say 9 minus 5 and 2 minus 0. Gives us 4 halves, which equals 2 over 1. Now let's do a big jump. Let's say from 7 to 13, which would be 1 to 4. So 13 minus 7 and 4 minus 1. What is 13 minus 7? 6. 4 minus 1 is 3. And that still simplifies to 2 over 1. We have that proportional relationship here. Okay? So quick reminders. Slope-intercept form is that y equals mx plus b. M is your slope. And b is something that we're not talking about just yet, and that's your y-intercept. And that is that starting point that we have over here, that one-time fee, a starting point, something we already have, okay? The independent variable is the x value, and the dependent variable is the y value, okay? So that is linear relationship representations.